Hey guys, so just a quick video about installing RhinoCam, setting up your machine, and then some rudimentary stuff about it. I don't actually have it installed on this machine, so good opportunity to do it together. You want to be coming to mexsoft.com, download RhinoCam 2014, the link up top there. Hit enter in any browser. You don't want the download demo, you want to download this. For the couple that are buying my machine, you've got the dongle, and for the fella in Perth, you know who you are, you've got the dongle. So you just click this. You want the 64-bit version if you're using Rhino 5. I would highly recommend using that. Probably download both versions if you plan on using Rhino 4. I don't know, it's never occurred for me. To save time, I've pre-downloaded it. It's sitting here. I'm going to run it. Make sure your Rhino is not actually running at the time that you run this. And we're going to do an install. Right, I might pause the video for the duration of the install happening. It's rudimentary stuff. Just next. Repair. I already had an install in there. Let's go repair. Okay. So in your case, you've just gone install. I'm going to pause the video, save bandwidth. Okay, when it's finished, just hit finish. Then at that point, you can close down this window. I'm going to close down everything else we've got going on in the background. You can close down this window and you can start Rhino. So I'm going to click Rhino and let it start up there. This is a very slow machine I'm doing this on, so just bear with me. I'll pause that until Rhino is loaded. Okay, that's loading. I had it pre-installed on this machine, I didn't realize that. For those of you with a new install, friend in Perth, you're going to see a little dialogue popping up asking you to register your dongle. I think you've spoken to me that you already have had RhinoCam running, so I'm assuming that you've already got all of that right. I'm going to work in a very tight space over here due to the recording limitations that I have. Essentially how I use mine, I keep the machining objects window open and the machining job in this size viewport. It doesn't look great. I'll show you how that looks. Usually I pop this one down the bottom here, underneath that one. I'll move this window over for you so you can see what that looks like. And then usually that allows me to, you can see that I've got my machining stuff at the top and my tools and cutters and knowledge bases at the bottom. How you choose to use it is up to you. Okay, for this tiny window size we have, I might leave this out here. Let's see if I can pull that up. Come on. Wow. Very small bit of space we have there. Alright, so that's use size to there, that's use size to there. Let's close that window for now. Okay, so the first thing you want to do is set up the machine in the orientation that it has. Okay, so in the case of Mr Perth, you received your machine as a 5-axis and then you ripped the 5-axis off and you've now made it a 4-axis, so you need to go in here. For the people from Albury, don't touch this configuration. When you're here on Friday and Saturday, I'll set it up with you, and then don't mess with it if you don't have to. So for Mr Perth, you need to bring this guy down here, go manual definition. In your case, you're going to take this back to 4-axis. Alright, there's only one configuration head that you need, and then your rotary axis is on X, which is accurate, which is correct. So most of the defaults for here are fine. Once you do this, you give instruction to RhinoCam that it's working on a 4-axis machine and not a 5-axis machine. All right, it changes the way that the world works. Is there any offsets in here? Let's take those back to zeros. These offsets in here have to do with my 5-axis. I'm just busy fixing all of this again, and we go okay. All right, I don't want to get too much further into it than that. You will have a post processor which you need. I have found, for what it's worth, if you're using 4-axis, that the regular, where are we? That the regular Model Maker, Model Master, Model Maker. Where's Model Maker? Model Master. There. That the regular Model Master settings work, or otherwise a Mac 2.3, which is up here. There. A Mac 3mm will work perfectly fine for you, not a problem. The only thing with this is it limits your speed to about 800 mil a minute. In both your cases, not an issue. Alright. I have a special one built for my 5-axis, which is this one over here, because there's extra instructions for a 5-axis that are required. the post processor I'll give to the people that bought my machine, and to Mr Perth, when you do your 5-axis, I'll pass this along to you as well. So in that second menu, the post processor options, that's sorted. All right. The next thing that you need to be able to do before you can write a path is tell the machine the tools, and this has been asked by a lot of people, so I think it's about time I do a video. You need to tell the machine what tools you have in your library. I have tools pre-configured, so I'm going to go, where's our view tools, RhinoCam, no, where's my tools, tools, view. Somewhere was a tool browser. I've closed the tool browser and I'm not sure how to reopen it. There we go. Alright, so this is a new version of RhinoCam to me. I'm still operating an old version of RhinoCam. So click that little button over there, opens your machining objects. You'll see that I have a set of tools preset which actually mirror the physical tools I have in my workshop. You will have nothing in here. I'll give you both a copy of this, but it's of no use to you if your tools don't actually match what I have. Alright, so I'm going to show you how to set up a new tool to match the tools that you do have. Let's open up a Bits and Bits web page. Is that Bits and Bits? No. Bitsbits.com. Bits. WordPress, engraving cutters. There we go. So this is where I buy the majority of my cutters from. You'll find some cheap ones on eBay depending on what you're doing. So a little bit about the types of stuff you had. Sorry, I have insane dogs which I'm about to go outside and stab with a garden fork. Okay, so the majority of the tools you'll be using are tapered ball end mills. That's when you do really nice cutting. And then the regular spiral, the regular pyramids, the pyramid tools in high-speed steel. You don't need carbide. All right. Now I want regular pyramid tools, not spiral pyramids. Okay, come on. All right. So let's have a look at those tools and what these settings mean. Let's set up this tool over here, which costs $9.50 a tool. Okay. You can see that it's got a shank. Okay. It has a tip. It has a cutting edge. The shank has a diameter. Okay, so let's, I don't know if I can grab that image out of here and save it so we can reference it later. The information you need about this is all in here: the side angle, the cutting length, the tool length, the cutting length, the width of the shank, the whole catoots. All right, and it's a 20-degree cutter. So let's go back in here and let's say that we want to make a new cutter. So we're going to go create or edit a tool. It's going to pop up this window. Up the top over here has a whole lot of different profiles of tools. Alright, we're just looking for a tapered tool, not a V-mill. It looks like a tapered tool, but it isn't. Taper mill. So we're after a taper mill, which is this guy over here. Okay, we're going to tap on that, and it's showing me a tool that doesn't look a lot like what I got, but if you have a look there, you can see what you got. And you can see that in my taper tools, I've already set up an existing one. I'm going to go make a new tool. Where can we make a new tool? Alright, let's just go back in there. Alright, so we know that, let's go back to whatever this tool was that we were looking at. What is its tip size? Okay, now you're going to have to bear with the Americans because they've got their retarded measuring system, which no one else in the world uses except for them, which is probably why their country is going down the drink. 001, what is 001 is 25 micron, I think, 24.5 micron. The majority of the tools we're using is 004, I think 005, which is 0.127 millimeters, something like that. If you work out from retardo measuring system to a real measuring system like the rest of the world uses. So 0.127 is the tip size. Your cutting length is 8 millimeters. So let's go in there and start looking at this. So the name of this tool, we're going to call it make it a name that you can remember, because when you go into your toolbox you're going to be looking for it. It's a tapered pyramid, and if you want to, you could put the Bits and Bits part number in there. Find the Bits and Bits part number for this. They don't have a part number. Part number, there we go, 815 PY20. So if you know that if you've broken it, what to order. So 815PY20 is the part number for the tool. Okay, I like to be descriptive in my naming, not like that. Up to you. You have to work out yourself what you're doing. I'm going to go. It's a 20 degree, and I like to put my size in front. Its tip size is an 0.127 millimeter 20 degree pyramid. That way when I'm running through my tools, you can see the one that I've named over there. Okay, I can quickly see what it is, the size, the wall angle on it, which is important when you're working out how not to cut stuff. I'll get to that a little bit later. Okay, the holder diameter is the actual holder, the cutter on the top. You put in if you want. I think it's about 18 millimeters or it's 23 millimeters or something for the chuck mouth, which is that guy up there. All right. The holder length. This is just to work out clashes. Don't worry about it. Put in anything you like. Put in 25 just for kicks. All right. Okay, so that's the chuck that holds the actual tool. It's got nothing to do with the tool so far. Okay, so now we're going to the shank diameter. Tool, flute length, shoulder length, tool length, flat diameter, shank diameter 0126. I don't know how the hell that ended up there. Shank diameter is 3.17 millimeters. Okay, which is the actual wall of the tool over here. That wall is always 3.17 millimeter for your cutter. Okay, the shoulder length I've got in here 10 mil from my previous tool. We know that the shoulder length is probably, if that's 8 mil, that's about 10, I would say 12, so I would put in 12 or 13 millimeters. I've got 10 in there, but let's go 12. Flute length is the actual cutting, the cutting section. Okay, we know now that they've said that that's 8 millimeters in there. That seems unreasonably. Sorry about that, had a bit of a computer glitch happen over there. So where were we? Alright, so we've put in the shank length up the top there. Now we're going to go to the tool length. The shoulder length of the tool, the flute length of the tool is actually probably about 15 millimeters. Okay, there is no corner radius of the tool because this cutter is flat on its tip, it isn't round. Alright, so there is a 0 corner radius, and I'm going to kill those dogs. And flat diameter of 0.127 millimeter. The taper angle, which is half of the actual angle is 20 degrees. If we go back to the website, right, the actual angle is 20 degrees. In fact, the taper angle is half of that, so half of that is going to be 10 degrees. Okay, so 10 degrees. So now you can actually see the cutter shown up over there, pretty much the way that it looks in real life. All right. So we're going to give that a name. We've done it, 20 degree pyramid, and we go save as new tool. Yep, and you're done. So that 20 degree pyramid will now show up in our tool library when we open it. All right, so let's load. I need to save this tool library. So once you've made it, go save the tool library. I'm going to overwrite that one. Give it a second. Okay, so where is she? 0217 20 degree pyramid. So you've made a new tool and you've entered it into the library. There's a variety of different tools. There's straight cutters like this. Okay, flat mills, 317s, which you use for roughing out. I've got 1 mil, 2 mil, and 3.17 in my library standard. I'll copy this library to both of you, and you'll get an idea of how these things are set up. All right. Okay, so you've set up a tool. Now I close it. Once I've set up my tools, there's not really a reason to have it open, because you're going to, when you set up a path, you're going to have the tools in there already. Okay, so the next thing we need to do is try and make a bit of space on the screen to fit all of these things. Let's make a basic ring. Hang on, I think the question actually from Mr Perth was how to do a flip. Alright, so we're going to draw a flat thing. And let's extrude it, and we want capture on, solid is yes. Okay, so we have a disc over there, and we're able to now start producing some sort of path around it. So if you know what your piece is, imagine it's a pendant. I'm keeping it simple just for illustration purposes. You need something that goes around the piece that you're going to cut. So I'm going to draw another circle, and you need to put some supports in there, and you need a bit of space to be able to work with it to cut the supports off afterwards. So you put a circle in there like that. You know, how many supports do you need for this? Probably 1, 2, 3 supports or something like that. So I like to just maybe draw a line. Here out to there, and I just pipe that to make just, I don't know, probably about a 0.8 mil support is ample most of the time, alright? So you can see in that window what we're doing, and I'm going to array that times 3. Array polar around F4, 3 items. Okay, so we have 3 supports holding it into the wax. Now imagine in your mind's eye that there's a block of wax over here, alright, which represents, let's do a rectangle. There's a block of wax in the machine represented by this, and what you're trying to cut out is that. This disc here is what you're trying to cut out. So you need to use this as a constraining curve to tell the pathing application, this is where I'm going to be working inside. That's what this curve's purpose in life is, alright? Then if you're cutting from 2 sides, which is not always necessary by the way, but if you're cutting from 2 sides, as Mr Perth has advised he's trying to do, as you would do with a pendant that's hollow in the back, for example, you need to cut from 2 ends. You also then need to tell the machine where the middle of this item is on your milling machine. So I usually just take my constraining curve and I patch it. Alright, I don't know why there's that many U and V spans in there, but okay. Alright, so I just patch it so that I have a ground plane, if you want to call it that, and that ground plane is running directly through the middle of the piece, so that when I cut from this side and then I cut from the other side, the cutter won't go past the middle. Alright. So now that we have the basic parts that we need for this, let's get into the actual pathing part. I'm going to see if I can do it in one window so that it's not as confusing. Not really. Alright, anyway, so you've got the machine set to 4-axis, your post has been set up, and so now you're going to go to setup 1. We're going to turn on our machine sys, says that Z is up, okay. We don't need anything else in there. Tool path levels we don't need on. World system we don't need on. World sys you only need when you start going 5-axis, okay. And stock visibility we don't need. So I'm going to grab this outside curve over here. I'm going to go to 3-axis, because at the moment, even though we have 4 and 5-axis set up, the actual cutting that we're doing, we're only using 3 of the axes, X, Y, and Z. So the cutter is going to move in X and Y across the part, and it's going to go up and down in Z to cut it. The 4th axis, which rotates it around, is not actually being used for this operation. So we're going to look for the tool in 3-axis operations, and we want a parallel finishing. There's many things in here. I recommend watching all the videos. However, that being said, the one that gets used most of the time is parallel finishing. I don't, half the things in this menu, I don't even know what they are. Alright? I use what I need. So you go parallel finishing, and it pops up this little window going, alright, because I had that pre-selected, it already knows it's in there. In the very first tab, it's saying drive region is selected. Had you not done that, let's close this and let's not select anything, and you go to 3-axis and you go to parallel finishing. You'll see that there's nothing in here. And if you try to write a path now, it's going to automatically look for the furthest extents of the entire screen. It's going to try to write a path up to this curve. You can now go select your drive containment region. In other words, where are we going to write path up to? Up to you. Enter. Alright, so we have a drive region. We have an area that the pathing is going to stay constrained to. Now the next tab is our tools. So let's use our 20-degree pyramid that we just made. Now why we needed to set that tool up is if you look at this angle of the disc, the angle of the disc is 90 degrees. When we tell the tool that, when we tell RhinoCam that the tool has a 20-degree taper to its tip, it knows not to go in past a certain amount, because what it would do then is it would cut the part too small by the amount of angle of the tool. So instead, when it comes up to this, it will actually offset the tool by the depth over the width over the height to make sure the tool doesn't cut into the part. You don't need to know any of that. As long as you set up your tool accurately, RhinoCam will take care of all of that for you. Alright, so you don't need to worry about that. So the next tab is telling the tool this is what we want to use. All right, feeds and speeds. Basically all the time you can set this to 400. They really should make this sticky at RhinoCam. This is an ongoing issue. You can save it as part of your tools, I believe. If you create new tools, not the way I've created them, but you create a brand new set of tools, the new RhinoCam has a way to save these settings to a tool. You'll have to figure that out on your own. I've not bothered. Anyhow, there should be an option. You go make sticky, and then it saves this for your machine as a basis starting point. All right, the speed of your spindle. It doesn't really matter what you type in over here because you can control the spindle from Mac. However, I like to default it to about 12,000. Slower than 12,000, you risk chipping cutters. Higher than 12,000, you risk melting wax. 12,000 is pretty much a good RPM for the spindle for the kind of speeds that you're going to start on. Once you start cranking up to 1,600 or 2,000 mil a minute, then this needs to be increased. That's a little bit more advanced. We'll get there when we get there. Clearance plane is where will the cutter move to when it's if let's say this had multiple pieces, there was a bit of a head over here and there was a bone, there was 3 or 4 pieces, where would the cutter move to safely get out of the way of wax and come down to start cutting the next part? If you were cutting 3 or 4 pieces in a block of wax and you happen to know that the block of wax was 10 millimeters high, in other words 5 mil above Z and 5 mil below Z, then you would know that it's safe for the cutter to be 5 millimeter above the part. So automatic is going to set it really high. You can go to the part plus 6 millimeters. Then it knows that, okay, I'm going to go to the part plus 6 millimeters above the part to get it there. And now the cut parameters. This is the most important part. This is the setting. All the rest of the stuff you're going to go next. You're going to get so used to seeing them, it's just going to annoy you. This is the first time you have to think. All right. Now this becomes time and money. Time and money is reflected in how long the machine takes to cut a part. If it's a draft part, leave it stock as it is over here. If it's a final part and you want a really, really good finish and you want it really, really accurate, you start increasing these tolerances. Going up higher than 0.01 will increase the mathematics that RhinoCam has to do. It makes no difference to you, it just means it takes longer to write a path. But at 0.01 and 0.01, I've been cutting stuff for the last 6, 7, maybe 8 years on milling machines that are 10,000 times better than Prince will ever be. You can increase that to 0.05, 0.005, 0.005, half of that. It will, all it does really is it makes it twice as close to the surface, in other words twice as accurate, but it also increases the time it takes to path by 2. So it can bite you in the bum if you're not careful. If you were cutting with 2 lots of cutters, you would leave stock. In other words, if you were using a big cutter to get the most of the wax out of the way, you wouldn't want to be hitting the actual part. You would leave stock in here. You would say, I'll leave 0.5 millimeter of border, if you want to think of it, leave 0.5 millimeter of extra thickness of a safety buffer. Then in the next fine cut, you would come in and remove the stock with the final cutter. In this case, we're just going to leave it on 0. Cut control is all about, is it going to cut in one direction only? When a cutter spins and it's traveling in this direction over wax, if it is rotating in the same direction, if you follow my mouse, if it's moving like this and it's rotating in the same direction as the cut, there's an upcut. If it's moving this way but it's traveling in the reverse direction, it's a downcut. The difference between an upcut and a downcut, the one leaves a lot of swarf and the one's a lot cleaner. Makes no difference to you. All of these are relevant to metal. Just tick mixed. It just means it goes zip, 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 zip. With an up and a down cut, it goes cuts, picks up the cutter, comes back, cuts, picks up the cutter, comes back, picks up. With a mix, it goes left, right, left, right, left, right, left, right, left, and it just cuts. All right, so no headaches. Angle of the cuts. Your milling machine is set up in X and Y. When you look at the milling machine, there's the back of the milling machine. There's the rotary over there. There's all the goodies. Your machine is set up to move like this and like this, so you can move it either in X or you can move it in Y, or if you wanted to move at this angle because maybe you've got a texture traveling across this piece that moves at more or less 45 degrees, this is where you would change the angle that the cuts happen at. All right, I just leave mine on whatever the default is, which is 0, which means it's going to move this way. All right. Okay, now over here is tool diameter step over. All right, I set it to distance, and for a small cutter like we're using, I set it to roughly, these are, you'll have to see for yourself when you cut. I call 0.07 millimeters or 70 microns draft. I call 50 microns okay. I call 30 microns very good. And I use 10 micron when I cut very, very fine detail, like family crests where there's minute little detail. For simple stuff like this, 005 will be fine. 0.05, which is a 50 micron step over. Okay. And basically, you're going to hit generate. Now what you want, and this is what Mr. Perth was asking about, is when it's finished cutting this and you're going to instruct the machine to roll, think about it in your mind's eye. The last thing the cutter does, the cutter comes down, it's busy cutting up. Now the cutter's point is down on the metal. Then we're going to tell the rotary, roll this thing around because I want to cut the other side, but your cutter is still down here, so when it starts rolling, you're shoving a big piece of wax into the cutter. And a whole lot of things will start going really crazy, and the machine starts screaming at you and problems. That's because you didn't come to this last little guy over here called entry exit. Entry exit is what should the cutter do to get to the wax, and what should it do when it's finished with the wax. All right. When it's exiting the wax, what do we want to do? I wanted to move it in a linear direction away from the wax for about, on the milling machine in my house, about 90 millimeters. All right. I don't need an angle on it. I just need a retract. There's the retract. The length of the departure. All right. Departure motion, vertical distance, departure motion is departure motion is 90 millimeters. Okay. And linear is about, put in about 5 millimeters. Whatever it is, just keep it in there. Okay. And let's have a look at what happens when we finish writing the path. You're going to generate it. This little guy runs up. Oh, it happened too quickly. So the cutter's going to come down, which is the yellow line. It's going to come down here. It's going to go ziggy zaggy, ziggy zaggy, ziggy zaggy, ziggy zaggy, ziggy zaggy. It's going to do all of the stuff. Okay, and I made a mistake over there. We'll go back in and edit that. Okay, so in the entry exit, that angle needs to be about 45 degrees. Actually, it needs to be 90 degrees. And let's generate again. No, not again. All right, let's do it again. Entry exit. Wrong thing, sorry. Vertical distance 90, angle. Okay, so the retract motion, which is this guy here, needs to be 90. Needs to be 90 degrees. Let's generate that. And it moves it straight away from the wax. We don't want it pulling away into the wax when it moves away. So it's going to come down, it's going to cut, and how you can quickly have a look at whether that's going to work or not for you is you can click simulate. So I might have to slow that simulation down. Let's simulate. Okay, and you can see what the cutter is planning on doing. And you can see that the cutter has moved over the wax, over the supports, and you're all ready to go. Okay. So obviously the only thing left to do now is we need to now tell the machine that we're cutting from the other side. All right. So we need to, let's get out of the simulation mode. We need to tell the machine that we're now going to roll it over to the other end. Sorry, spraying ants. All right, so you've finished the top. What I like to do is name this. I like to call this top. It just means if you ever come back to this file again, you know what the hell you were doing when you did it. Okay. So we've cut the top. And from your CSYS, from your machine sys, you can see that the cutter, this blue line, is telling you that the cutter is coming from this direction. It points towards the cutter. We need the cutter on the other side. In other words, we need our rotary table to turn this part around to cut the other end. So at this point, you highlight the last path and you go to setup, and we're going to go to rotate table. Okay, so we need to rotate the table 90. Nope, we need to rotate it 180 degrees because we want to get to the other side of the part. Okay, so we go, okay. So now you can see what's happened is you now have the cutter coming from the other end of the part. You're still looking at it the right way, nothing's changed, but the cutter is now coming from the other end. RhinoCam understands that we're now working at the back. All right. So I don't need to do all the work we did. We know that everything we did up the top there was fine. I'm going to take this, I'm going to copy it. I'm going to highlight the other end of the table and I'm going to paste it in there. Alright, and I'm going to regenerate that. And so now we have, if we look at this entire part, we now have it cutting the top, we have it retracting a safe distance away, we have it spinning the table around to the other side, and we have it cutting the bottom. Okay. Now the beauty of RhinoCam and the reason I used a big part like this is you could put this exact same information you have here. You could now not have to do all that work again. You can simply delete this block. I'm not going to actually physically delete it. You could delete this and you could put your pendant down inside the same circle, and then you could just draw the supports to it and go regenerate, regenerate, and then you could take that pendant out, you put the next pendant in, you go regenerate. So without having to do everything that I just went through manually, you could save this file as a template and simply delete this part each time, okay, and make these longer till they touch whatever part you put in it. So you could swap out parts as frequently as you liked. You could put this pendant in there, you could put a disc hole, you could put whatever you want. Once you've done this once, it's not finished. All right. So let me put something else in there just to show you what I mean. Let's do something roughly the right size. Let's turn on its points. Sorry, I want to. Let's do something like that. And let's imagine this was a pendant that you made. Alright. So now because we've done everything, I don't have to do all the work again. I simply come over here, regenerate. Okay, and it's written a new path to go over all of that. And I simply come down here and I regenerate. And with 2 mouse clicks and simply copy pasting a part in, I've now got a template, if you want to call it that, for cutting pendants. So I have on my own machine, I have a variety of these templates, some this size, some square, some round, some oval. I do the work to set them up, and then when I need them I just pull them in and voila, finished. Okay, I'm going to stop at this point. I'm running out of time with the kids, and glad to meet you guys on Friday, and happy to fly down and see you in Perth if you're still stuck, mate. Cheers, Chris up.